everyone, my name is Giancarlo Villadorino.
Hi, my name is Gian Paulo Resuena.
My name is Gian Crisi Alegre.
Pattern mining. Pattern mining concentrates on identifying rules that describe specific patterns within the data. Market basket analysis, which identifies items that typically occur together in purchase transactions, was one of the first application of data mining. So, in simple word, ito yung paghahanap ng pattern sa mga data, which is nakakatulong sa isang company lalo na sa business. Dahil dito, mas makakagawa sila ng mas magandang decision based sa makukuha nilang pattern. At yung market-based analysis ay yung una na in-apply sa pag-data mining.
So, for example, the strategy they use in supermarkets. Supermarkets use market basket analysis to identify items that were often purchased together. For instance, a store featuring a fish sale would also stock up on a tartar sauce. Although testing for such associations has long been feasible and is often simple to see in small datasets, data mining has enabled the discovery of less apparent associations in immense datasets. Of most interest is the discovery of unexpected associations, which may open new avenues for marketing or research. Another important use of pattern mining is the discovery of sequential patterns. For example, sequence of errors or warnings that precede an equipment failure may be used to schedule preventative maintenance or may use to provide insight into a design flaw. So, marami nga pwedeng paggamitan ng pattern mining. Hindi lang siya basta-basta ideya o paraan. Pwede din siyang gamitin sa pagtukoy ng mga sira o maaaring pwedeng masira ng mga kagamitan sa paraang pagmomonitor dito from time to time.
Frequent Itemset mining. One of the most well-known and often used data mining techniques is frequent itemset mining. It was originally designed for market basket analysis, but it is currently utilized for nearly any job requiring the discovery of regularities between nominal variables. Frequent itemset mining is a data analysis method that was originally developed for market basket analysis. It aims at finding regularities in the shopping behavior of the customers of supermarkets, mail orders, companies, and online shops. In particular, it tries to identify sets of products that are frequently bought together. FPM has many applications in the field of data analysis, software bugs, cross-marketing, sales campaign analysis, market basket analysis, etc. Frequent item sets discovered through a priori have many applications in data mining tasks. Tasks such as finding interesting patterns in the database, finding out sequence, and mining of association rules is the most important of them. So, ang frequent item set mining is ginagamit sa business, which is ito ay technique for marketing kung saan malalaman natin ang possible choice of buyers. Ito din is nagagamit in finding the shopping behavior of the customer. It is like if a person buys food, then he most likely to buy drinks.
Contents. Item set mining methods. Pattern mining in multilevel. Mining in high-dimensional data. So, ito yung mga i-discuss natin sa presentasyong ito.
Let's proceed in item set mining method. Association mining searches for frequent items in the dataset. In frequent mining, usually the interesting associations and correlations between item sets in transactional and relational databases are found. In short, frequent mining shows which items appear together in a transaction or relation. Need of association mining. Frequent mining is generation of association rules from a transactional dataset. If there are two items that represents X and Y purchased frequently, then it's good to put them together in stores or provide some discount offer on one item on purchase of other item. This can really increase the sales. For example, it is likely to find that if a customer buys milk and bread, he or she also buys butter. So one of the association rule is when you buy milk and bread, you may also prepare butter, or we can say in simple words that the seller can suggest to the customer to buy butter if he or she buys milk and bread. In this technique, we can adjust or develop the sales of a particular company.
Important definitions. First, support. It is one of the measure of interestingness. This tells about usefulness and certainty of rules. 5% support means total 5% of transactions in database follow the rule. Second, support A implies to B is equal to support count A union B. Confidence. A confidence of 60% means that 60% of the customer who purchased a milk and bread also bought butter. Confidence A implies to B is equal to support count A union B is divided to support count A. If a rule satisfies both minimum support and minimum confidence, it is a strong rule. Support count X is the number of transactions in which X appears. If X is A union B, then it is the number of transactions in which A and B both are present.
Number 3. Maximal item set. An item set is maximal frequent if none of its supersets are frequent. Number 4. Closed item set. An item set is closed if none of its immediate supersets have same support count same as item set. Number 5. K item set. Item set which contains K items is a K item set. So it can be said that an item set is frequent if the corresponding support count is greater than minimum support count.
Part 2. Pattern mining in multilevel. Mining multilevel association rules. Items often from hierarchies, flexible support settings, where items at the lower level are expected to have lower support. So yun, kaya tinawag siyang items often form hierarchies dahil dito sa ML association rules ay gumagamit tayo ng hierarchy information encoded transaction table kaysa sa original transaction table. This is because a data mining query is usually in relevance to only a portion of the transaction database, such as food instead of all the items.
So there are two kinds of multi-level association. First is flexible support and the second one is the redundancy filtering. First is flexible mean support. Threshold, some items are more valuable but less frequent. So once a store bought some products that is very minimal because it is popular, many customers will attract to that product, and since it is limited, it will become less frequent.
Mining multidimensional association. We have a single dimensional rules, multi-dimensional rules, interdimension association rules, hybrid dimension association rules, categorical attributes, and quantitative attributes. So in single dimensional rules, buys X and milk, buys X and bread. Multi-dimensional rules, 2 dimensions or predicates. Interdimension association rules, no repeated predicates, like age X 19 to 25, occupation X and student, buys X and go. Hybrid dimension association rules, repeated predicates. Age X and 19 to 25, buys X and popcorn, buys X and Coke. Categorical attributes, finite numbers of possible values, no ordering among values. And quantitative attributes, numeric implicit ordering among values.
Mining quantitative associations techniques can be categorized by how numerical attributes such as age or salary are treated by. So first, statistic discretization based on the predefined concept hierarchies or data cube methods. So yung quantitative attributes ay na-discretize na bago ito minahin sa pamamagitan ng predefined concept hierarchies o data discretization techniques kung saan yung numeric values ay papalitan ng interval levels. And alternatively, yung transformed multidimensional data ay magagamit sa pag-construct ng data cube. At itong data cubes ay well-suited para sa pagmimina ng multidimensional association rules. They store aggregates in multidimensional space, which is essential for computing the support and confidence of dimensional association rules.
The second is dynamic discretization based on data distribution. So, the discretization method is the process through which we can transform continuous variables, models, or functions into a discrete form. We do this by creating a set of contiguous intervals or bins that go across the range of our desired variable, model, or function. So, continuous data is measured while discrete data is counted. So, in this technique, we can easily manipulate the data distribution once we gather it specifically.
Number 3, clustering. Distance-based association. One-dimension clustering then association.
And lastly, fourth, statistical test. So which is the example is sex is equal to female and their wage mean is equal to $7 per hour and overall mean is equal to $9.
So part 3 is mining in high dimensional. High dimensional denotes that there are dizzying amount of dimensions, so much that computations become incredibly complex. The number of characteristics in high dimensional data can outnumber the number of observations. Microarrays, for example, which monitor gene expression, might include tens of thousands of examples. So example 1 is healthcare data. High-dimensional data is frequent in healthcare datasets, where the number of attributes for a single individual might be enormous, such as blood pressure, resting heart rate, immune system status, surgery history, height, weight, existing conditions, and many more. So in high dimensional, hinahandle daw nito yung iba't ibang technique sa iba't ibang larangan upang maresolbahan niya ng maayos yung napakaraming data na maaaring kumalat o di maayos na pagkukontain sa mga ito. So example lang nga daw dito yung healthcare data high dimensional. Dito, syempre, sa isang healthcare facilities, maraming mga nangyayari na activities. Kagaya ng pagkuha ng mga blood pressure, yun nga, kagaya ng resting heart rate, pagkuha ng immune system status, tsaka na rin yung surgery history, pagkuha ng height, weight, existing conditions, at yung iba pa. Marami rin pwedeng i-apply ang high dimensional, lalong-lalo na sa mga businesses tsaka sa iba't ibang kumpanya sa ating bansa.
There are some unique challenges for mining data of high dimensions. The first one is the course of dimensionality. The complexity of many existing data mining algorithms is exponential with respect to the number of dimensions. With increasing dimensionality, these algorithms soon become computationally intractable and therefore inapplicable in many real applications.
Secondly, the specificity of similarities between points in high-dimensional space diminishes. It was proven in Bayer et al. 1999 that for any point in high-dimensional space, the expected gap between the Euclidean distance to the closest neighbor and that to the farthest point shrinks as the dimensionality grows. This phenomenon may render many data mining tasks. Example is clustering. ineffective, and fragile because the model becomes vulnerable to the presence of noise.